Live. Totally forgot to check my Wi-Fi here. Let's see which one I'm on. Reconnecting. It says reconnected. All right. I'm gonna let this go a few minutes anyway, just to give a chance for a couple people to connect. Look at this freaking lovely mess. I'm trying to get my little uh, phone down on a little tripod here. Got one person connecting. I'm just gonna set the phone down for a few seconds, let it go. If anybody starts connecting, let me know if it's the quality is okay and whatnot. Let's see. Here we go. I want to get in my own stream here so I can see if I get into the chat. Just to check it. Come on. And if it's crappy, then I'll just try to go to the cellular connection. I see the chat up there, but it's not showing anything on it yet. I see the chat on screen. Looks good, you said? All right. There we go. All right, chat came up. I'm going to pop it out. Man, you can tell I haven't used stuff for a while. It's like asking me to do things for like the first time. I'm going to go ahead and close that stream there. It's my own stream. Let's see here. Come on. In the windows. There we go. And we're right here. Cool. You can tell I really thought about this. Actually, I was just highlighting some of my documents and things like that and going through them. And then I thought of grabbing the phone and going ahead and making a recording. But then I was like, I just don't really feel like doing all the editing and all that stuff. So just, just screw it. Do it live. Do it live. People who have seen that old video clip will know what I'm talking about. People who haven't will just think I'm nuts. So, all right. I think you can still slide this over a little bit. So we're talking about a soft start, namely this Micro Air Easy Start device. I noticed that when I went on HVAC Talk, a forum, which is something we used to use years ago. It came up in the 90s, and it's probably not very popular anymore thanks to YouTube, but that used to be where we all went. And I did find a couple discussions there, and it was the exact same discussions. Some people saying these things are awesome. They really help with you have a generator, whatever, so you can get it started, on that reduced power. Of course, the same thing would apply for a solar inverter like that for starting a compressor. But then you got people in there saying, no, those things are just garbage or they're just a gimmick or whatever. So it's not totally worthless. I just don't think it's what people think it is. I think some people are claiming that it's a soft start in the nature that it's a variable frequency drive as it ramps up to make the compressor start easy. I don't think that's what it is at all. It's a little on the gimmicky side, but it's got a lot of, high quality components in it. So you can kind of see why it costs so much, $400 or whatever it is. But I think it's just mostly just a timed start relay, to tell you the truth. So let's just go over this little video clip right here. I just clicked. This is from Micro Air. I don't know if it's theirs or not. Let's see if we can do. We go to the theater mode here. I don't know what it is, but everybody likes to use a Goodman for these tests. But let's just go over this little clip here. Hopefully the volume is loud enough. Turn it up a little bit. But they have a little current sensor hooked up to some sort of device trying to capture the inrush a little better than just using, your regular multimeter. Some of these do have minimum max. Some of these are a little better than the others. Like this one's made for VFDs. This one has 3-phase input, tells you direction, all that kind of stuff. The true way to see this is with either oscilloscope or with like one of those Fluke power analyzer things, which I got to use once some years ago, trying to figure out power, for power factor correction and stuff like that. But those are really expensive, like $8,000 or whatever they were, 5,000, I don't remember. But you could record and see everything. Those are pretty awesome. But so this seems to just be capturing your inrush. Now I'll say what this guy's doing. I've noticed the exact same thing. It is a comparison. It's just not the same as looking at your instantaneous like locked rotor amps, your peak inrush, and then how it ramps down with the sine wave. And that would be, I guess I should have like pulled up a diagram, but Rheem, somebody says, I don't know. It sure looks like a Goodman. Oh, it is a Rheem. Ha! You're right. Dang. Well, there was a lot of good ones in there, but that video, you're right, it's a Rheem. But anyway, on your this is just one cycle, but if you have a bunch of cycles, 60 times a second, and so when you put, first apply the voltage across the winding without any rotation, you get just with the full, you just think it's a long stretched out wire, right? And before the magnetic field comes on, it's gonna like your amps are gonna follow. There might be some lag to the voltage, but it's gonna go up. Peak. You guys have all seen this before. And this is just gonna be crude, but as the speed of the compressor gets up, then you're gonna just have your normal, current following the AC sine wave. So this time here is like 1 second is like from here to like way out here. So your little clamp on meter doesn't capture that. But depending how fast that rotor gets turning, this will either look like that or it might look like, it'll stay a lot longer. And I've seen Kickstart actually show it on a scope, and this right here is what you're measuring with your meter and time, is how long before it drops down from locked rotor amps once it gets going. Plus you get the saturation, I guess, of the magnetic field also will drop it a little bit after the first initial spike, right? But then it's going to start dropping down, with the speed of the compressor shaft catching up to the frequency of the rotating, fields. So if you put a start assist, you get a lot more torque, and this turns into this, and that's the whole point of putting like a 521, a true potential relay start capacitor, or whatever. I did a test like way back over 10 years ago. You guys could find it where I hooked up an old oscilloscope. The one I still have it. I made like a crude little current sensor around there, and then I converted the amps to volts so I could just see it on the scope, and you could kind of at least just see how long it was taking. It wasn't one I could capture or anything like this. It was an old school oscilloscope, but you could still see if it was how much current by reflected in the DC line that would go up and drop down. It was way better than using a meter, and it was pretty awesome. So we were putting like no hard start. I put a PTC, positive temperature coefficient ones. Those are what people also call soft starts a lot. But they this thing, don't want that going to sleep. They work by the temperature of the current going through them is what makes their thermistor coefficient in there like go from low resistance to high resistance real quick with the current going through it. And then what happens on those is if you turn the unit off and restart it within just a few minutes on a hot day, they're worthless. They have because they're still hot, so they don't conduct again. So you want a potential relay, with a start capacitor generally for the most current. I'm looking to some of the chat so I can catch up before we get ahead of me. So somebody's going, you just installed a Goodman, so don't give me no crap. You guys are talking to each other. All right. Guys are going at it with you. Goodman does suck. We always have to maintain that. But anyway, I don't want to go on and on with that, but that was that old video I did years ago. And it just showed, PTCs versus potential relay start capacitor type hard starts versus those super boosts. Super boosts for a long time were using gimmicks. They either put a PTC in series with the start capacitor, which again, worthless on a restart, totally has to cool off to work again, or they were using what they like to use was a circuit board in there that was a fixed 1 second on no matter what, which is, if you have that extra torque, that could be like 5 times too long to be holding it on, and that's bad for the start windings. So, and I remember looking at that, Kickstart they actually did a pretty good job, showing that the differences, and they actually brought hardware and did it right in front of us. It's like 20 years ago. It was pretty cool. I have noticed that Super Boost now does have like a 2-wire that's using a start capacitor. So I don't know if they leased the copyright or if the copyright's over for Kickstart, because Kickstart came up with this idea of just wiring the thing, and it actually would still work with just 2 wires, and you could didn't matter which way you put the wires on, and that was the whole thing, man. And they had a true potential relay 2-wire for like the longest time where nobody else did. So anyway, how this started was a couple days ago. I was just watching some videos, and so like right now, like if I go on YouTube and I'm logged in on my HVAC one, which I just mostly use for this. If you're on home, besides showing all the girls the guitars on their boobies, and I don't use this account for watching the music videos, but it's funny how those are still there. It's like a lot of this stuff, but there's like a lot of do-it-yourself kind of stuff that was popping up and stuff, and I just clicked on a couple of them. Oh, this might be interesting. You know, get the clickbait right with all the like this type of stuff, and you just click on it. That does look like one worth watching because it does look like something let the smoke out. So that's the kind of stuff I'll click on. So, God, these new names do look like good ones, don't they? So I was watching one the other day, and the guy was just pushing in the contactor. But the thing that, and honestly, the thing that kind of got me kind of like, you know, disrespecting it, I guess, was because it was aimed at homeowners. And I'm sure most of you guys will agree. It's like you don't think that if somebody doesn't know anything about electricity or anything, I mean, showing them how to like put in fan motors and capacitors and contactors and stuff is a little on the sketch side, just because there's real easy to put reverse any 2 wires and then the compressor's toast, right? So you didn't do them a service then. So whatever, it's his right to do yourself videos if he wants to, though. But I just noticed that when he had pushed in, you know, the contactor here, you know, that there was a delay before his compressor started. And I thought, oh man, I bet you had pushed that a few seconds ago and your compressor was probably off on IP. But he replied and he said, no, I have like a soft start. I'm like, what? I don't see no soft start. And it was kind of a setup like this, right? Just real simple Goodman or Rheem or something. But he replied back. I go, I don't see nothing like that. And I'm looking at the wirings and kind of explaining it. And then some other people chimed in when I asked about it on my YouTube comments, whatever, put a picture of it or something. So anyway, eventually it led me to this easy start. And so we're talking. I go, I see a start capacitor in there. So if it was like variable frequency drive type thing, they're not going to use that. They're going to just, you know, ramp up the frequency or something probably. I don't think you would be able to keep that in there. But some people were thinking that it is, and then I looked at HVAC Talk forum, and some people thought there might have been a real soft start or whatever. And I guess I kind of skipped the other point. Was there's something called a soft start, which is basically for compressors, which is a variable frequency drive, essentially, but it's not rated for continuous duty. It's a small one. It's just to get the compressor or motor going, and then after it's running at full speed, there's a changeover, you know, contacts, switch over, you know, and it switches to line power directly because it's up to 60 hertz. You don't need the electronics just to do that. It's just to get it up to frequency. So those are called soft start, like Burnshaw makes them and stuff like that. Burnshaw soft starts and stuff. So they're calling this a soft start. I guess you better to zoom in instead of moving my camera here. But they're calling it a soft start, which is kind of like bugging me because I know soft starts are electronic. I'm like, is this just using some relays? Because the guy told me in the video, he says, no, it starts the outdoor fan first, and then after a delay, it starts the compressor. Well, looking at what these are commonly been used for RVs or maybe people, you know, because of generators, that makes a little bit of sense. Especially on a RV unit, you're probably pulling a decent amount of power on that one motor that runs 2 blowers, your outdoor fan and your indoor fan, and then you have a little tiny rotary, 115 volts usually. So I guess breaking those up with 2 relays or something, for example, to make them start separate might be just enough, you know, to help your generator start it, especially if at the same time you're adding start components, which gives you more torque. You get your compressor up to speed faster and doesn't have that inrush current as long. So, but anyway, I'm getting distracted looking over there and everything, but I'm like, this ain't no soft start. But anyway, I was also probably a little wrong thinking it was just a couple relays and some timers. I was like, it's probably just a gimmick. So let's just start here. This guy's got like this one here. This is from Micro Air, and they're going to show you just reading like the current for comparison. This is before adding it. Now I'll tell you, he's not going to get all the inrush current. The inrush current, like I had drawn up here, is going to be your locked rotor amps, and if it's a 5-ton scroll, for example, it's probably 160 amps at the first instant you throw that power. But then it drops quick, especially if you had a start component, but even without it, it's still a fraction of a second, and then it drops down to run load amps within a second or so without the hard start. And your meters are not fast enough, and even that one's not fast enough to capture it, but you probably can repeat it and get some sort of value, which this guy's going to get. And I've done the same exact thing that this guy's doing, is a before and after comparison. So it is a comparison. It's not the real inrush amps. But it is a value to compare.
Once we have the Easy Start installed. So here we go. We're going to start the compressor without Easy Start and see what the peak current is. All right. So there it goes. Running it for a little bit.
By the way, that outdoor fan motor is toast on this unit this guy's using. Listen to those bearings.
Here, and then we'll
So he got 77 amps. Depending on the size, you guys know the new ream numbers. What are the 1436? Was that 14 SEER 310? So single phase, I don't know what your single phase 230 volt scroll is pulling for locked rotor amps. It's probably closer to 100 or something, I imagine, for single phase. So he's got that value. It's not all of it, but it's probably repeatable, and it's still a good value just for comparison later. So that's fine. So they're going to go and install this thing, which they install it in here, and basically I noticed that they're pulling off the run wire, and so the wire's going to go in here and then come back out, and that's how they're delaying the compressor. And then they're also adding a wire to the start cap because it's going to connect to this start cap, electronically in here, and doing stuff like that. So what's happening after they install this is when they push this contactor in, you immediately get the power to your outdoor fan like normal, but then this thing adds a little delay, and then it starts it up a little quicker. So let me see if I can find where he's got his after. He's getting ready to stick his pen in there or whatever.
Very first 5 starts that Easy Start carries out, it optimizes its internal parameters here, and here we go.
So you got fan at 4 amp.
What you see is that through the run capacitor, 5 seconds later, Easy Start.
So it goes to the compressor. So that is reading just peak. So it peaked at 4, which that piece of crap motor pulled 4 amps to peak, and then it did whatever it does, for the start sequence, closing the run, circuit and doing whatever it's switching with the start capacitor, and then it shows 19 instead of 70 something. Now here's the thing: is when I've added like a hard start, like a good one, I get the same kind of result. It's so much quicker that your sample time and measuring the peak current is way less. So the arbitrary value, it's comparable. It's just not reality. It still would have the same initial peak, with no rotation, no magnetic field, but it's just not going to capture. It's just so much quicker that the new value is like 20 instead of 70 something. So it is definitely way quicker starting, but of course they got a start capacitor and all the electronics in there. So I don't want to go too much into it, but I'm just trying to figure this thing out. So I finally kept looking. I don't want to buy one of these for $400. I don't think any of you suckers is going to give me one because they're $400. I really wanted one in my hands because I want to dissect it. Sometimes I take some apart and it's like way better than I thought it was going to be. And then sometimes, or a lot of times, you take gimmicks apart and you're like, dude, this is a total freaking gimmick, man. This is for suckers. Just put a 521 in there and be done with it. So there's probably a few benefits of this, but it's going to show you why it's not a soft start. It's just some delays and some tricky stuff in there, so here is it apart. And I found somebody had a video, and then after I found the video, the guy actually had a web page with all these high quality photos. So this guy did a lot of work for me getting this up there. So I'm going to try to get. So that's the inside of it when you take the cover off. This is the back side. I added a bunch of labels to it. I'm trying to figure it out. So we're just kind of look at this together. I'm not going to have I'm not going to be absolutely sure how this thing works. If I had one and I could kind of look at the traces and from front to back and everything, probably figure it out a little more, taking guesses at what they're doing. But here's like 2 relays which might be in parallel. You could see one side of the high voltage power, little big fat traces going to it. It might be both of them just being used in parallel to handle the load of the compressor. I'm kind of thinking that is what it's doing, because I don't, probably not connected to the start capacitor. And your start capacitor is here and here. This is like, so you can see this goes to the one side, and then this is to the kind of the other side, the common side of it or whatever, going over back to your this is going back to your run capacitor also. So it's basically between run, which I labeled, where is it? I labeled this one wrong. This is run. L1 run, basically, or L2. It is actually, I'm sorry, this is L2. This is run. I missed this label. So here's run. So this is taking run and just paralleling this capacitor between run and the other capacitor. That's what they're doing. So I missed the label on there. But they're doing some of it electronically. So there are some other pictures. So here's your relays, and here's some just little small transistors, resistors, and then your little diodes just, stop the little, what do you call it, back EMF out of the relays when they open so don't blow up the little transistors. Pretty basic stuff there. L2 white wire connects here, and it's hard to see, but there are some really big traces. I'm trying to figure that out. I'm looking at the front and the back, and then basically this is just flipped over though. So everything that's on the top over here is on the bottom over here. So like the capacitor all wiring comes out down here. And I can see right here, it doesn't really have, yeah, you can see this is real heavy trace material. It's kind of hard to see what it connects to and doesn't right over here. Here's a fuse right here. We'll see this on the front when we go through here. So I mean, there's a lot of quality parts on here. It's just not a real soft start. It's not a variable frequency device. There's the relays on the side, so it could be 2 of these flipping in parallel. I'm not sure. Maybe the microarray guys will chime in. Of course, a lot of the reps aren't the guys that engineer it, so they don't really have much of a clue unless the engineer chimes in. But there's some SCRs up there. I thought, they could be MOSFETs or whatever, but I looked them up. These are just what I do with it too. I got it right here. These are just SCRs. They're not triacs, so as you see, they're unidirectional switches for phase control applications, heating and motor speeds, blah blah blah, and they're just this gated SCR, silicone controlled rectifier, whatever. So they're just like a diode when they turn on, and you got to put 2 of them in the opposite polarities to do AC, which like you could do like what you see in light dimmers or crude speed controllers like your ICM 333 or whatever it is that does your outdoor fan motor. It's just crude, or even Motormaster 1 or whatever. They're just triacs, or which is 2 of these in parallel opposite polarities. They don't do anything to change the frequency, and I think that's what I actually had this up here for. I've shown this stuff before, but basically you have your 60 hertz, right? Saying this could be just continuing, as it goes, but you have no, current flow, but you could, wherever you set the gate voltage or the voltage to hit the threshold of your gate on your SCR, right? You can set it here, right? Which will then, you're usually on the opposite, this SCR and the other polarity, you're going to set the same thing. So basically what we need to do is it's going to do nothing until it hits there, and then it's going to, all of a sudden it's going to go right up to where that voltage was and then carry on the rest of it. And the way that SCRs work is once you could take the gate voltage away and it just stays conducting, until it's 0 crosses. And then once it's 0 crosses, it's going to stay off until it hits that other one, and then it's so it's a wave clipper, if you've ever heard of that. So they just look at real crude, and it repeats that. And then if you move this up higher, like to run the motor slower, right, like on an outdoor fan motor, then this will get changed to where it's going to be off until like right there. So it's going to be like off, and then it's just barely going to catch the peak, and then drop down, and then it's going to be way off and do the same thing. So you just have a lot more off time in between, but it's going to pull full freaking current when you apply this to the freaking windings right here at this time. It's full current. So it doesn't, and that's why if you ever put like an amp probe, across an outdoor fan motor, and you put one of those ICMs on there, it never drops your current. Your current actually the RMS actually seems to be higher. And it's just because the motor's speed is never catching up to the 60 hertz, but you're like chopping off the beginning of the sine wave to slow the motor down. So it's like it does slow the motor down, but it's a really crude way. It gets hot. That's why you also need ball bearings, for the oiling and everything. Just, variable frequency drive actually, will vary the frequency too. But it's not just like a triac does. It actually just uses pulses to shorts and then longs and then shorts. Like if we're doing use your DC bus and you're just going to do the polarities, you're just going to do like a shorts, with a little more gaps, and then you're going to keep making it longer and then shorter. Oops, the voltage is always the same, by the way, in the VFD and IPM modules and all that stuff. And then you're going to flip that and do the other way. And it's just across the inductance of the motor windings, magnetic fields and everything, you're just going to get like an average, So at full 60 hertz and, and everything, you're going to, get something like that. But then when it's first starting out slower, usually you could pull back the pulse width modulation and make them a lot shorter, which if you look in the voltage characteristics in your VFD, it calls it as voltage, but it's really just like an RMS trick. The voltage is always all or nothing. So when you rectify your 230 volts inside, is this 330 volts or so DC, and then it's going to just switch the polarity with MOSFETs. And I know I haven't been looking at the chat or anything for a while, and I'm just rambling a lot, but I just thought I'd just make this video just so people can look through and see why I'm saying that it's not a soft start. So here's something I was actually building. Like here's like an IPM chip. Actually blew up one, but put another one on there. That one works now, but that's like for 3-phase. Or for brushless DC was doing, but I was going to just make something just to make my own little inverter thing. And it's just this 4 MOSFETs. And you're talking like MOSFETs, kind of like what was in that and on these. I have a bunch of those in here. I've been buying a whole bunch of stuff from like China. You always have to say it like that, like Trump says it. But like, somewhere in here I have a whole bunch of them. Oh, like here's some. Yeah, it's a whole bunch of those. Whole bunch of them. These are the high voltage ones. Yeah, 400 volts. So I could do a 230 volt, AC. I was going to step it up. I was going to take 170 in right to my high voltage DC, rectified from 120. You get 170 DC peak to peak. And then if you just do so basically you have positive here to this MOSFET and positive to this MOSFET and then negative going to this one and this one. And what you do is you run with your microprocessor. You're going to go like this one. I'm going to go high in. I'm going to turn this on, which is going to turn on this MOSFET, right? It's a little voodoo trick that this has in there. It's pretty cool. These kind of have built-in delays and stuff. Some of these chips you can't do shoot through, they call it. And shoot through is if you accidentally turn 2 MOSFETs on at the same time with negative here and positive here, what's going to happen? You have no load. It just goes through the 2 and immediately explodes them. So you always want to never have them both on at once. So some of these chips are pretty cool. Kind of add like a internal circuitry that keeps these 2 outputs from ever being on at the same time. It adds a little bit of delay. So that's kind of cool. It saves you when you're building stuff homemade, So basically, if I go and turn this one on, and at the same time, or I do a duty cycle or something down to this low end, then I turn on this MOSFET. So my motor, for example, will be tied between the middle of each 2. So if this one's biased plus, this will be plus to this lead on the motor, and then this one's going to be pulled down the negative of the DC power, and then this other lead will be negative. And you can do pulse width modulation, pulse it or whatever. So at a lower duty cycle or whatever, or just so many milliseconds, just do it once. And then how long in between you go from switching the polarities is going to be your frequency. And that's why I was kind of looking and trying to figure out how many milliseconds in a 60 hertz, and stuff. I was kind of for programming the microprocessor. And I kind of stalled out, didn't keep working on. Plus this room started getting hot. But I did get the cooling on, and it was up to 85 setback, so I turned this on a little bit. And then so on the next cycle, you're going to turn on the low on this one and the high on this one, and what it does is then this lead of the motor is tied to MOSFET to negative, and then these pair which are always tied right to this lead all the time, this one's gonna go positive, which is gonna bring this lead to positive. So it's just back and forth, back and forth. Your the voltage would be 170 plus minus, then 170 minus plus, vice versa. And if you look at reproduce the sine wave, I think I should reproduce like a 330, 340 volt signal. It's basically like a bridged output, like you do car amps or something, right? So I'm gonna see. I haven't done it. So I've already had them running with a lower voltage. This thing only goes up to 50 volts, but I can kind of control it so I don't blow stuff up that limited in amps. And been doing it through here. I was powering like a fan, a 120 volt fan, just having quite enough voltage, but it actually worked. So I just need to build it on something better and then hook up high voltage to it and then keep tweaking from there. I'm thinking of making my own soft start now. But the funny thing is, like, this little rotary compressor outside, it just has, you know, its regular window shaker thing, and it doesn't like to be restarted too fast. I do have at least a 5-minute delay on break, but with it as hot as it is, and with the hot water, once it gets hot, look, I've overheated the water at 130. So I'll be surprised this thing's actually still. Actually, somebody must be using water because that's not that hot. It's pretty hot, but it's always cooler at the bottom of the tank. But it's coming back at 136. Like freaking hot. And yeah, it's killing my performance, my cooling a little bit. My suction line's up to 67, and my liquid line's 122. So this thing's kind of. This thing is when I want to use this room. Again, for those that don't know, the compressor out there is cooling this room, is heating the water at the same time. And I did add a little bit of outdoor coil, but not a whole lot, just to kind of keep it from pressure from going too high. But if I ever need to use this room, I just need to like run some laundry or do something in the afternoon just to kind of displace some of that hot water in that tank. And then the thing works fine. This thing kicks out, just cools like awesome. I can tell it's not that cold right now. Capillary tube system, and what happens if you reject enough heat, then you get more gas mixed with the liquid, and then it starts underfeeding and all that stuff. So, all right, I'm probably getting lost in this. Check the comments, but basically, that would be a soft start. Would be if you had this stuff, MOSFETs and a DC bus, so you could reproduce your pseudo AC, right? It's just pulse width modulation of DC, and then you just invert the DC and then do the same thing for the negative and then do it back and forth, and that's how inverters work and stuff. So you'd have to have the capacitors to be holding that rectified voltage and all that stuff, and there's none of that inside that deal. So I can close this probably now. So if we go back, to this whole picture, there's none of that. There's a start capacitor, and then you can see the filter. This is going to be like your line voltage going down, and then it looks like they use a regular transformer for some reason instead of like buck boost. They still might be using buck boost because there's a lot of capacitors. So there's a couple different voltages in here for control voltages. So there's a lot of electronics. There's money spent making this thing. Believe that, especially with the capacitor, all that stuff. There's money put into this thing. So, I mean, they not overcharging for the electronics in this thing. It's just not a soft start. It's just it looks like just some delays. They might be wave clipping the start capacitor, or just using electronics just for running, connecting. I'm kind of wondering if this is, instead of going across a potential relay, if they're actually doing electronically. But these are not the only SCRs. There's two right up here. They're kind of cut off. I didn't take these pictures, somebody else did, but they're nice high quality pictures. But here's another picture, and if you look on the back side, this is those right here, and I labeled them SCRs, and it's basically you can see between this line and going through the fuse and back over to run. Probably they're probably just regular SCRs, not triacs, so it's probably one for one player and one for the other, and then they got the two gates right here going electronics to drive it. So I have the feeling these ones are probably what's doing the start capacitor. They're not even on a heatsink or nothing, but you're talking they might be, I think they're timing this, or just doing electronically, like you use SCRs to run heaters, on a heatsink and everything, of course, but they might be just combining the capacitor in the circuit with the SCRs is what they might be doing. And I I'm still trying to figure out. That's why I need one, and I can't give you guys a definite answer if they're actually running the compressor current between run and that other line through these 4 right here. I would think it'd have to be 2. You can tell they're parallel together. Got a better picture somewhere in here. Oops, other way. Here they are. You can see that these are paralleled right here, and then these are paralleled, and this is gate. So, and then you can see that these are combined here, and then so they're doing something that could. I have the feeling they're just two. They're paralleled. 2 of them are paralleled, and then they're one for one polarity, one for the other of the sine wave. So this might, I can't fathom a big compressor up to 6 tons going through this circuit board trace, but single phase and everything. But I mean, maybe they're just initially giving a little, doing it through the triac and then switching to the relay. I don't know. But even if they're doing that, it's not a variable frequency. It's not like a soft start uses. It's just they're just doing some electronic switching with it. And if you, as you see with the fan motors, when you wave clip, it doesn't make the compressor or motor easier to start. It just usually slows it down when it's already running. So wouldn't imagine anybody doing that to a compressor. It wouldn't make any sense. So I'm still thinking that overall this thing just adds a delay. So your outdoor fan motor got started, drops to run load amps, and then they're just figuring out the perfect amount of time to engage and disengage that start capacitor instead of using a potential relay, or a fixed time is what I'm guessing. So maybe someday I'll get one of these to take it apart and kind of put it on an oscilloscope and everything. Then we'll know for sure. And here's another picture of it. But these are not MOSFETs. There's no capacitors in here to store rectified DC, so there's no way that's doing a variable frequency drive. And I brought in a board, from, of course, this is a blown up one. This isn't a variable frequency drive. This is an IPM inverter power module for a brushless DC compressor, which would be one of these circuits, basically. Right? So you have 3 pairs. Think of it as 3-phase. And you would do like a 3-phase VFD similar. It's just the way it's done. But as I've learned, when you're on brushless DC motors like ECMs and stuff, it's got feedback, which is this down here, to go to the microprocessor and know the relative position of the motor. So it pulses in that permanent magnet motor at the right time, which is what a lot of inverter compressors are. But for regular, just 3-phase or even single phase, you're just gonna vary the frequency. So you still have to have the bank of capacitors to charge up, which here's your rectifier. This is a 3-phase one in this case. The one leg goes directly to it, and the other 2 go through the bleed resistors, and then the relay, once it latches right after the inrush current to charges these up, and then you got your IPM power module here, and then your 3 outputs. It would be just a little less electronics to do a single phase. Like I said, instead of 6, you do 4, which is what my little diagram had of the thing I was building. And then you could do your, pulse width modulation to do to reproduce the positive, the sine wave, and then invert the polarity and do the negative, and then back and forth. So different pulse width, and then you also do the, pseudo, vary the frequency between the plus minus inversions, and then you have a variable frequency drive. So as I said, when you see in the curve, when you look on a variable frequency drive, it's just less pulse widths, so it's an RMS. The voltage is always fully applied, whatever that voltage is of the unit. It's never actually lowering the voltage. It's just the RMS is measured less because the pulse widths are shorter when it's first starting off, and then it brings up the pulse widths at the same time. It's also speeding up the motor, because you have to have the torque against the same load. So you'd have to have, anyway, components for that. Hopefully this video didn't go full retard too long and everything, but like I said, I just didn't want to edit and all that stuff. But the components are just not there to be a true soft start variable frequency drive. It's just doing some hocus pocus with the start capacitor. And the thing is, you wouldn't have a start capacitor with that other kind of circuits I was just showing you guys. So anyway, before I call it quits, we bring up the chat. SCR chops and caps smooth. Well, if you ever look at like a Motormaster 1 or a ICM 333, or I might be saying that model wrong, but you guys know what I'm talking about. The popular ICMs, I like them. You know, I use them, but they do eat up motors. Oh, it's 7 o'clock. Dang, this thing just shut off on me. Oh well, I'm almost done. That water was freaking hot anyway. 138 degrees at the top of my water heater. Look at that. That's set 130. That thing was scalded hot, man. I do have anti-short cycle in my own electronics up there. I need to redo that. Batteries are still fully charged, so all that's pretty much been running off the sun. Now we're just down to the power of this LED and computer in here. Get distracted, man. That's my thing. I don't finish shit. What was I gonna say? Someone was talking about. Oh, the ICMs and stuff. They just chop it. If you look at an oscilloscope, no, the sine wave looks like shit. It looks like that. It chops it, and then it varies how long it waits before it actually brings it on, and then you know, that's how it runs the motor slower. If you do the simplest way is just, you know, varying a resistance between, you know, the gate, you know, like a voltage divider with a knob just to move when this threshold's going to be. You could do it electronically. You could have a microprocessor looking at the zero cross and then counting so many milliseconds before it actually gates the SCR. That's going to give you the most control, because you could actually maybe gate it after the peak on its way down. You can't do that with just a voltage divider, because once you set a threshold, it's got to cross that threshold on its way up. It can't like skip it on its way up and then kick it on its way down. Not with just a voltage divider, but you can do that electronically. But they're crude. The motors run. You'll notice the motors you put on, you know, Motormaster 1s and ICMs and stuff, they run hot. But hey, if you run an AC in the middle of the winter for a server room, you got to do what you got to do, and having stable pressures instead of on off with, you know, with that kind of low ambient. The wave clipper is better. So, but the best thing would be a true VFD. But you can see with the cost, they don't even, you know, they don't use them. You don't get those until you get to the Motormaster 5s, for example, if you're talking about Carrier and everybody else's popular stuff. But it's like that's on 3-phase outdoor fan motors, and it's a true VFD, and then the motors run way smoother because it's actually varying the frequency, you know, and the pulse width. So ICM 870 soft starter is cheaper. See, now you mentioned another one, and I'm gonna have to look it up, and then we're gonna have to see if it's a soft starter, just like another, you know, thing that's not a soft start. Right? So how do you window? ICM 870. It's probably, and see, because my whole thing is they're calling these things soft starts, but they're just time delay things. Did I get that in there? Oh, ICM 8. It brings up these things. Let's see. Here we go. ICM's popular. Oh yeah, it's the same kind of thing. I found a Johnson Controls, a couple different ones. They're all the same thing as what I'm just looking at, probably. And some of them don't even break both legs, so they're just actually just a fancy timer or whatever, or sensor for the potential relay inside. It's not even a potential relay then. It's just electronically controlled relay to the start capacitor. So the ones like this one actually breaks the line coming in, and then the compressor run coming out was this brown wire. So it did break that. I found that out today. When some of them aren't even doing that. They're just paralleling up the capacitor to a start capacitor. But let's just say this is the same thing as this. It's not a variable frequency. So real soft starts are variable frequency start, and then they transfer over once they get up to start. You can just be a low, you know, spec variable frequency drive, you know, because it just needs just to get the compressor or motor going from a dead stop. Gives up the frequency for a couple seconds, and then a transfer switch bypasses it. And it's in bypass mode until the next start. Look up a Burnshaw freaking soft start. These are not real soft starts. Burnshaw, if I'm spelling it right? Soft start. Let's see if we can find one. Benshaw, yeah, that's it. series soft starters. Now these are basically VFDs with a transfer switch. I haven't seen them forever, but oh, that's a high voltage one. But medium voltage soft starter, Ben Shaw. I went to a class for these like 15 years ago. So that's why I just had it in my mind. Fully integrated programmable family class E2 load breakdown combination. I just want to click on one, see if there's any pictures of them. But they have the electronics in there. It's got SCRs in there, basically flip flops, like I said, one for each polarity, or it'd be three phase, you know. But you could do the same thing single phase, I guess, if you wanted to. And then once it gets up and running, it just bypasses. So this takes all the inrush out of a compressor, pump, all that stuff without being a full variable frequency drive that needs all the control perimeters and all that stuff. It's just taking away the true locked rotor amp inrush that you get, you know, every time a motor starts with a contactor or whatever, because it's varying the frequency with pulse width modulation and then gets it up and switches it. These things here are not able to vary the frequency. It's still always 60 hertz. The best you can do is wave clip, but I don't know why you would do that because that takes the torque away. So I don't think they're doing that. Until I see otherwise or see an explanation that's going to make me go, wow, I've never seen that before. And maybe these guys will show me something, but I'm kind of doubting it. I'm thinking it's just adding a delay so that your other motor that wasn't going through this is already up and running. 5 seconds later, then your compressor is going to start. And it might do some tickling with those, but then it's probably just throwing those relays and electronically paralleling in your start capacitor. And I think they're doing something to adjust that, but I don't even see any current sensors in this thing. So like you would have, like this thing's gonna have current sensors. Maybe it's not on this board. But most of like, if you look at any like VFDs, you look at the IPMs and all the VRF equipment, you'll see current sensors, at least on 2 of the 3 legs. But this doesn't, I don't think this has any of this. And something you could do it with shunts, which is what I might try doing, you know, which is like a shunt, and then you read for a voltage drop across it with a microprocessor, and that give you, and you can, you know, they could use a bunch of math and kind of get an approximation with that. But I don't really see any of that kind of stuff in here. They do have this right here, which is like probably a fractional ohm, and it was real massive. It almost looks like they're using this to shunt the relay right across the other potential down there. Kind of crazy. I don't know. It's getting warm in this room quick. This room gets warm quick. For those that don't know, this is like a little mechanical room out in my garage. My garage had this, like, this is the garage. I gotta add some foam, but it had this, this part was deeper because it's like offsetting like the laundry rooms over behind this wall. So it was like a really deep section of the garage over here. Like, right, this is where the car would park. So I'm like, dude, I'm gonna close this off. I already got my electronics in here for this. I should cool the room. And then I'm gonna make this my laboratory, and then I can get to like tools. I don't know. Have that noisy mill I have right out there. Anyway, soft starter's cheaper, he says. Let's see, where was that? Find a distributor. Well, I wouldn't. This probably ain't gonna tell me, but you're gonna have to go look. You know, you have to go look. But I think for somebody with that has just a little too much, you know, to start on their generator, they slap this thing on. If they could find all the controls, you look at the instructions, I mean, and think about it, a lot of do-it-yourselfers are doing this because they're desperate, and they're probably screwing their shit up. Because there's like generic instructions says, well, if your unit looks like this and this color wire and this wire, and again, do-it-yourselfers doing this stuff, it's probably not the best thing to be doing. But if they didn't have a good hard start, just adding a hard starts could make all the difference in the world. So probably putting a proper 521 or something on their little rotary compressor on their RV, or somebody's small single phase AC at their house didn't have that, you know, and they're trying to start off a generator or an inverter or something. Just adding the good 521 might be all they needed. But these things are going through and adding a delay, so it seems like it's just getting your outdoor fan motor started, and maybe your fan motors inside your house started, which would be true, you know, and then with the call for cool, and then 5 seconds later this closes the relay, adds the electronic means of the start capacitor, and gets your compressor started. And maybe somehow they're reading it to get to fine tune the right amount of time for the start capacitor, because if you keep the start capacitor too long, it also pulls crazy high amps. So that's, and anybody that had a stuck potential relay, you'll notice that the compressor sounds really weird, and then it kicks out an IP within just like another second or two. So there's definitely pulls some pretty crazy amps if you don't take out a start capacitor fast enough. So these things could be fine tuning that and making it work. So they work. It's just not a soft start. That's all. So, all right, 7 o'clock my time. It's getting warm. Hope I'm probably have to have maybe somebody start a load of laundry so this thing's set back to 85, but I don't want it running again with that water tank that hot. So I need to kick the thermostat up or have somebody use some hot water. And that's weird to think he heats water when it's cooling this room. So let me go just through these real quick. It looks like a lot of people were just talking to each other. Sorry, I wasn't paying attention. Somebody mentioned Ford Boss. Ford Boss and Ford Tech Mocha Loco, or whatever that channel is. Real good. I don't know if you guys know, but the F-150 got wrecked. So I don't have that no more. Had the EcoBoost that was mighty. And I didn't like the used truck market. I bought that Platinum used, and it was still one of the more expensive vehicles I had bought. And it was almost like just barely 2 years left on the loan, and it was going to be paid off, and then it got totaled. So I got a little bit of money for it, but I was like, I had that truck for 4 years, and the same year Platinum truck, they wanted as much as I paid 4 years ago because the truck market sucks right now. So, and I didn't want to downgrade the truck and get a slightly newer one. We looked, my wife and I went and looked. I go, you know what? I had a sunroof. I had all this stuff. I didn't have what the new F-150s had, but it still had all, had the off-road package, the FX4, which means you had that cruise control to go downhill and all that stuff. It actually came in handy. The tow package, 4-wheel drive auto as well as 4-wheel drive high and low because of the Platinum or whatever the package. I don't know. It was cool. I was able to put that in on pavement and it didn't buck. It freaking gave me all the traction. It was like a cheater. Little sleeper truck. It was kind of fun. It had the shifter and a console, not up on the tree. I liked it. That's why I got that truck. But I didn't want to get one that didn't have those features that was newer, and I didn't want to spend as much and start over a loan for the same exact truck. So I went and got just a Hemi Jeep SUV. It's pretty cool. It has the air suspension and paddle shifters, and it can still tow my Can-Am. It's just not a truck. And maybe in a couple of years, I'll just buy some used truck for some truck duty and not have a fancy truck anymore. I don't know. But anyway, all that because somebody brought up the Ford Boss. So I'll have to watch some Dodge stuff or whatever. But yeah, I've been a Ford guy. But we've also had quite a few Dodges. We've had several minivans. Had a Dakota, had a Durango, had a Ram a long time ago. Anyway, it looks like everybody's kind of slowed down here anyway. Or something happened to the chat. Doesn't look like it's even moving. So somebody said a long time no see back on the water heater. Yeah, but I simplified it a couple months ago. I don't have that separate unit on there. I just tied all my high wall into the one compressor I was running already on the little old condenser skid I had out there. Turned into an evaporator. Doesn't have a. So anyway, yeah. So go ahead and get rid of that stuff. So basically, yeah. That's just my take on that. I might find more. If any of you guys, one of these is blown up or something, you change one out or just change out a unit has one. I'll have to see if I could get that from you so I could kind of dissect it. If it works and I can hook it up to something, maybe we can, get one of my scopes hooked up. It's kind of sketchy to hook this one up because anytime you have something on line voltage power, you hook up, the ground lead of this to one of the legs of potential, goes through this in the ground and blows the scope up. But I have these little cheap, handheld pocket scopes, which work good enough. It just isn't going to capture automatically. But you can, with the camera, it'll capture, we can pause or whatever. So, Joe, someone offered me one as a rental. Well, they ain't going to want to rent me something that might get blown up. And somebody noticed that they soldered in this fuse, but I actually understand that because getting bounced around and stuff, this could get loose from all the current. It could get hot. It gets hot, it gets even more loose, it gets more hot, and then your fuse is blown. So I actually understand them soldering that in. They don't intend somebody to go fix it, I guess. And if this fuse blows, it's probably got fused SCRs or something in there anyway. Someone said, just join. It looks like soft starts for RVs to enable starting AC. It is, except for I don't think they're calling them soft starts, and they're not soft starts in what I'm familiar with called a soft start. And so I already showed it. You can rewind or you go look up like Benshaw soft starters and stuff like that. They're basically SCRs or whatever, are kind of like parts of a variable frequency drive to do variable frequency starting and then switch over to line voltage. Just enough electronics to get it started, you know, with at the lower, you know, ramp up frequency. This can't ramp up the frequency. So you have to rewind and see the wave clipper. I think it's doing with SCRs. I think it's just doing that for the start capacitor and stuff, and then some timer and a relay. And it's using, like I said, 2 relays in there. I don't know how much. And people were getting defensive, but you know it's true. After the contactor, you're coming out and going into this thing. Here's an L2, and then your run is up above up here. It's going through these relays, these little plastic relays. They do say 50 amps at 277, you know, but you know, remember your contactors are like have LRR, locked rotor amp ratings for when it clicks. So even if these are in parallel, it's not, those little contacts and they're not comparable to a compressor contactor. Now if they're tickling it with some SCRs and then switching this over right after the compressor gets its rotor turned a little bit, maybe that's how they're getting around it. I don't know. This thing might actually be pretty impressive as far as what they are doing with it. It's just not a variable frequency ramp up. It's just, you know, it's just a delay and some fine control on the start capacitor instead of using a fixed timer on a relay or a, you know, potential relay, or like what Super Boost used to do, which was destructive, which was using a full 1 second holding circuit no matter what, even though the compressor was already started. So that was like a not good on compressors, what Super Boost did. And I've seen probably more of those start kits out there than anything, just because they were cheap. But that's what they did to not violate Kickstart's true potential relay 2-wire kit they had, until now everybody seems to have them. Anyway, I'm getting out of here. It's getting hot. It's up to 83 now. You know what's cool about Ecobee? It's like a Android phone almost, man. It like updated, and then all your graphics are new now on here. I don't think you get that in a Nest. So I'm just gonna turn this up for a while. There we go. And I can of course get on. You know, I have 3 of those Ecobees now, but the water tank's way too hot for that thing to run. I'll have to tell someone to take a shower or wash clothes with the hottest waters they could use. Isn't it funny? I wash my laundry in the hottest water possible now. Because I want to drop the temperature of the tank sometimes for when this AC is running in here. It's using the same compressor. And this was my circuit earlier, I was saying, but close that. All right, I got to go for real. So let's check it one more time. Yeah, check, just rewind or whatever. I ramble a lot. I just didn't feel like making any edits, and I just said, screw it, I'll just record live. I haven't done a live video in a while. And you can check it out. So there's a lot of electronics in that thing. Not saying it's a piece of shit gimmick. I'm just saying it's not a variable frequency, you know, thing. It's just there's some hocus pocus in there. It probably gets just enough of the job done for people with RVs and stuff, but I don't see the point in putting it on a home one. I'll say that at the end of the video. There's no point in this on a home AC. Just stick a 521 on there. With that, catch you guys later, man. Night. Barbecuing.